Let matrix C be equal to the 2 by 2 matrix 1, 2, negative 1, 3. Carry out the indicated operation, C inverse. That is, find the inverse matrix of C. To begin that process, we write the augmented matrix where we have 1, 2, negative 1, 3, vertical line, and then we have the 2 by 2 identity matrix 1, 0, 0, 1. We want to perform row operations on this augmented matrix so that we convert this part of it to 1, 0, 0, 1. So I've written that augmented matrix here, and I've written that the first row operation we will do is to add row 1 to row 2 and replace row 2 with that result. You'll see in a moment the reason that I've chosen to do that is when we add row 1 to row 2, 1 plus a negative 1 is 0, and we were looking to get a 0 in this position. Then we add 2 plus 3 is 5, 1 plus 0 is 1, and 0 plus 1 is 1. Notice that row 1 did not change because we were only making a change to row 2. Once again, we perform an operation just on row 2. We're going to multiply by 1/5. So row 1 stays the same. 0 times 1/5 is 0. 5 times 1/5 is 1. 1 times 1/5 is 1/5, and 1 times 1/5 is 1/5. So I've written that matrix at the top here, and we wish to perform the following operation. We're going to take negative 2 times row 2, add it to row 1, and replace that in row 1. The reason we're doing this is we're attempting to get a 0 in this position, and that would involve multiplying row 2 by negative 2 and adding it to row 1. So let's begin. Negative 2 times row 2. Negative 2 times 0 plus 1 would be, of course, negative 2 times 0 is 0, plus 1 is 1. Negative 2 times 1 is negative 2, plus 2 is 0. Negative 2 times 1/5 is negative 2/5 here. We add that to 1, which, remember, 1 is 5/5. So negative 2/5 plus 5/5 is 3/5. Negative 2 times 1/5 is negative 2/5. Added to 0 is negative 2/5. Well, now if we see on the left-hand side, we have the identity matrix for a 2 by 2 matrix. 1's along the diagonal, 0 in the other positions. That tells us that this 2 by 2 matrix is the C inverse. So C inverse is 3/5, negative 2/5, 1/5, 1/5.